Hi, you guys. This is Mrs. Bolin with your one proportion review for exam 3. And I'm going to go ahead and jump right into the question here. This is the one about the Canadians who own a pet. I'm going to assume you've already read the question, so I'm just going to go over the solution. So for part A, it says to state the parameter of interest, which is P, the true proportion of Canadians who own a pet. B, P hat would be our statistic here that we found that 610 out of 900 who own a pet. So we got a value of 0.677777. I rounded it here to the third place after the decimal, but you'll see later, depending on where you round it, our answers might be a little bit different. The null hypothesis is that the proportion is 70%. And the alternative is that it differs from 70%. It doesn't say whether it's above or below, it just says that it differs. And our significance level here is alpha equals 0.05. My alpha looks a little squishy there, kind of looks like a fish. All right, so let's go ahead and look at question number 2. Question 2 asked for the name of the test in part A. So this is a one sample Z test for P. Then it asked for us to check the conditions. So yes, it was a random sample, and that allows us to generalize the results to the whole population. 10% condition, yes, 900 is more than likely less than 1/10 of all Canadians, less than 10%, which it obviously is. And that allows us to sample without replacement so that we can fulfill that condition for having independent samples. That pulling out one without replacement doesn't affect the chances of getting another one with a success or without. Okay, then large counts here. We have a sample size of 900, and then we use the assumed value in our null hypothesis that the proportion is 70. So 1 minus 70% is 30%. When we multiply those out, we see that there will be at least 10 people in each group, which tells us that the sampling distribution will be approximately normal, and to find our p-value, we can either use table A or the normal distribution, which is where table A comes from. Moving right along to question number 3, we need to plug in the numbers for the do portion of this, and we are finding our test statistic. And so it's just like, remember when we found our z-score, we're just taking our value, we're subtracting from the mean, or in this case is the parameter that we're looking at, which is 0.7, and then we're dividing by the standard deviation, which is 0.7 times 0.3 divided by 900. Again, we are using p, not p hat, and the reason for that is that we are assuming the null hypothesis is true. So that gives us a value of negative 1.455. Actually, when we plug it in to Staplet, it does. If you plug this straight into Desmos, it would be a little bit different. And I'm going to switch over right now and show you that. We also get the p-value from that. So I'm going to switch over to the technology piece of this and show you guys how you should be entering this. Just a minute here. Okay. Oh, no. This one. There we go. Sorry about that. Oopsie. All right. So if you look at the data here, we know that has a pet, 610. Doesn't have a pet, 290. You can put whatever you want right here, but if you put something that is in the context of the question, it helps a little bit. Then you're going to scroll on down here to where it says perform inference. We are doing a one sample z-test for Canadians who have a pet. And our hypothesized proportion is 70%, so 0.7. And then make sure that you guys look at this alternative hypothesis here. I put the not equal to because we want to show that it differs from 70%. So we are going to have a two-sided or two-tailed test. And the test statistic that we get here is negative 1.455. The p-value of that test statistic in either direction, so negative 1.455 or lower, or positive 1.455 or higher. So just really quickly, if you were to use Desmos and type this in, I didn't get 145. But look here, when I change how I round it, if I start putting in sevens right there, I get a lot closer to that 1.45 that they had in Staplett. So that was just kind of a rounding, the reason why mine wasn't exactly 4.5, it was 4.4. And then if we used a normal distribution here, this would be the same thing as using table A and doubling the value. And so we just said outside a region. So if we went negative 1.45 in one direction, we would also go that same distance from the middle in the other direction. And so I just set it here with a mean of 0, a standard deviation of 1, because I have a standardized value. This value right here is not necessarily in the context of any problem. That's my standardized value. That tells me how far that test statistic is, or that is the test statistic. It tells me how far my statistic is away from that the null hypothesis, okay, from that parameter that we're testing. Okay, so let's go back really quickly if I can figure it out. Oh man, you guys. Okay, so here is back to our paper. And so as you can see, I put in the test statistic and the p-value from Staplett, and then I drew a little picture. Here is the hypothesized value from my null hypothesis. In the null, they said we're assuming that it's 70%. Here is the statistic that I got, the 610 out of 900 people. And so that's how I got that value. And then because we would go the same direction, the same distance in either direction, because I just want to show that it differs from, that's why this would be a two-sided test going back to the alternative hypothesis, which is not equal to as opposed to a greater than or less than. If it were greater than or a less than, you would just use that one-sided value, but because it could be differs, it means it's either above or below. So we're counting both of those areas, okay? So looking down to question number 4, now is our conclusion part, now that we have that p-value. Well, because this p-value is so large, 14% chance of it happening just due to normal variation in that sampling, we fail to reject the null, okay? Because our threshold was 5%. If it's less likely than 5%, we're going to say, wow, that's really unlikely. And so we would reject that hypothesis, saying the chances that we got this were not that great. Whereas here, if it's greater than that value we determined at the beginning, then we know, well, it could happen by chance. So we don't really have convincing evidence that the true proportion of pet owners is different from 70%. So then B, it says, based on your decision above, what error could have been made? Well, we know that when we fail to reject a null, when it's actually true, or when it's actually, when we do have evidence for the alternative hypothesis, that's a type 2 error. So in that case, the proportion of pet owners differs from 70%, but we didn't find convincing evidence to support it. So the consequence would be that we would think 70% was true when in fact it was not. And so whatever decisions then are made based on that proportion could have consequences. I'm not sure what decisions you're going to make based on the number of pet owners. Maybe if you're trying to open a store and you need it to be 70% for some reason, and it was or wasn't. Okay, so that would be the consequence of a type 2 error. And then for this last question, we're using the same prompt, but now we're creating a confidence interval. Okay, so we're plugging it into the formula to find the point estimate, which we already did, our critical value, which for a 95% confidence interval is 1.96. And then we're plugging in our p hat values, not the null value from our test. We are plugging in our sample values here, our statistic that we calculated. And then again, you guys have a couple different ways to use technology on this. I'm going to go over this and then I'll switch to the technology and show you guys everything at once. So anyways, I will show you in just a minute how I got that interval from Staplett. And then our conclusion is that I'm 95% confident that the interval from 0.647 to 0.708 captures the true proportion of pet owners in Canada. And so the question for C was, does this interval support your decision from the test that we did? Yes. Remember, we failed to reject. We said, it's possible that we don't have enough evidence to say that the proportion's different than 70%. Well, if you look at our interval, 70% is in that interval of all the plausible values. Okay, so because 70% is included, yes, we were justified in it, or it supports the decision that we made in the test that we just did. Okay, and then the last one is, how large of a sample size would we need in order to have a confidence level of 95% and a margin of error of 3%? Okay, so we're going to plug into the formula that they gave us here. And so I plugged in my p hat, 1 minus p hat. I plugged in my critical value for a 95% confidence interval level. And then I also plugged in that margin of error of 3%. I put it all in Desmos, and I will take you there in just a minute. And this is the value that I got out of it. Doesn't matter if this is 0.8 or 0.1, we always round up because this is the minimum value. And since you can't sample 0.1 of a person, you need to go to the next integer above that. Okay, so we're at, or it actually would be a whole number because we're not ever sampling negative people. Okay, so 932 would be the correct value. I'm going to switch over to the technology here. And so when I was looking at the interval, I plugged all the stuff in exactly the same. You don't need to go to a different place. You can just use the same one that you ran your test on, but you're going to select one sample Z interval. See, you guys can, there's all the different tests, intervals, all that fun stuff for one sample. Okay, so I'm at a one sample Z interval, and success is has a pet, and I'm changing the confidence level to 95%, and then performing the inference, and it gives me that interval. So I just copied that down. If you wanted to work it out the long way, you could go to Desmos and you could type it in and do a minus there, and then you could change it to a plus and get the other value. Again, I rounded it a little bit different, so our numbers are going to be slightly different than what it's giving us in Stapplet. Okay, and then here's what Desmos looks like for that last problem about sample size. So we have p times 1 minus b hat, we have our critical value, we have our margin of error on the bottom, and we have that squared. Okay, so that's the answer we got, and we rounded up. So that should do it for the one sample proportion problem for the review. Your problem on your actual test will be pretty similar to this, so make sure you understand how to do all of this.